Hey guys, Werner Berry here. I'm going to show off the BerryBot. A few people on the forum asked some questions about the hot end and about the magnetic joints that I've got. So I'll go ahead and I'll disassemble it and take a little closer look at it, and hopefully you guys may be able to use this on one of your future projects. It's been a pretty good machine. I've only got about 12 prints off of it so far, but man, I'm really having a lot of fun with it. I printed this off this morning, and if you haven't done one of these things, it's that little gear project from Thingiverse. It's really amazing. Anyways, I don't know how well this is going to show up with this light. This is a dust grate that I use. I think that might work better. We'll try that. Anyways, this is pretty much set up to operate. What I usually do if I want to remove the hot end, it's just really simple. I usually take a popsicle stick or something of that sort and stick it right here in my filament feeder, just to free up the filament. Then I can just pop this off. Let me find my cutters here and I'll chop it. So then I just go ahead and chop it there. I've got a few plugs. These little plugs here that you'll see when we get closer in are just Dean's connectors used in RC modeling, and I really like them. They're heavy duty, and they make a really good connection, carry a lot of current. So as far as disconnecting the magnets, it's really quite simple. I usually leave it somewhere in the upper position, and then if you grab it, you can just pop one off, pop the others off, and just let them dangle there. And that's it. You got the hot end all separated. It makes it nice to work on in the bench, or you could have a couple of these, you know, even with different colors. The magnets have really been working out great. And we'll go ahead and zoom in and take a closer look. A lot of people were asking, they were getting confused about how this was working. The ball's actually the magnet, and then these are JB welded into a socket here on the hot end. These tubes are nothing more than a piece of carbon fiber, 3/8 with a 1/4 inch ID, and they've just got a like a cap head. It's actually a shoulder screw that's been concaved with a 1/2 inch ball end mill. And so I mean, these are really quite simple to make. The thing that's interesting, I tried different size, different lengths of bolts, and it seems like 1.5 is more than adequate. 1.5 inch long gives you enough magnetic pull that it works very effectively without adding a bunch of weight. Great. To reassemble it, it's pretty much the same process in the opposite. You just go ahead and just snap your balls back on. Just like that. Go ahead and pull some of the filament out. Just realign the filament and lock it in. And then go ahead and plug in your connectors. So I mean, it couldn't really get any easier. One other thing that I did, somebody was asking about, was the feeder. And my feeder I actually have just sitting up here on magnets as well. That's the only thing that holds it. So literally to change out my feeder, or to work on it, or do something on the bench with it, it is really literally as easy as unplugging it like that. So there's 4 little magnets here. I've got 4 matching magnets on the top with a little rubber pad, and that makes it really nice to work on the bench as well. So let's take a closer look at these things and go from there. Well, here we got the hot end. We'll take a little closer look at this. It's pretty much all aluminum, and this end effector could have been made a lot easier. I ended up machining these little adapters for the balls, magnetic balls, but it really could have just been a thinner. This is about, I think this is 1/8 inch that I used, but it could have actually been something like a 90 thousandths. And 50-52 aluminum is really easy to work with. It bends very nicely. Where this is 60-61 and a little rigid. Anyways, if I was to do it over, I'd probably try 90 thousandths, and I machined it out on my CNC, and it could have been done with a dimple in the bottom and then epoxying the balls onto the dimple. Would have made it a little bit lighter and probably a little easier to manufacture. You know, the one thing that's important, probably the most important, is getting these bends as accurate as possible. I have a sheet metal brake, so it's rather easy to do, but if you were careful, you could even do it with a hand brake, I think, pretty effectively. This little piece of tape I put here playing around with it, it makes a huge difference. I'll probably end up making something a little more permanent, but it makes a huge difference. The slightest bit of air running over this aluminum block, as you guys probably have figured out, really cools it down. So it comes up to temperature in about 2.5 minutes roughly from cold, as long as I don't have any air from my little tiny fan blowing on it. So I just put the little tape there to diffuse it, to keep it away from this aluminum block. But I'll make something a little nicer, a little more permanent. Anyway, this right here is the key to my extruder working so well. And I say that on the forum, a lot of guys have figured this out. Having the air run over this, it keeps the juncture between the aluminum block and the rest of your barrel, you know, at maximum opposites. In other words, this is getting up at 245, and just right there at the nut over here, it's literally cold. You can touch it and it doesn't even feel warm. That's how much it dissipates the heat. So my extruders really worked flawlessly, and I think that's a real big key to having successful prints. By the way, I appreciate a lot of the stuff that was on the forum. Most of this stuff's new to me within the last 3-4 months. And I learned so much by reading everybody else's posts. That's one of my main reasons for doing this video, to try to show some of the stuff that has worked for me and that I learned. This little assembly right here, this is just an aluminum collar I bought from McMaster Car. And it's just a standard. It's got a 3/4 inch bore. The OD is like 1 1/4. Already comes with the set screw. I did put a little piece of Delrin in the end of the set screw where it's cup shaped. Normally it's sharp to dig in, and I didn't want that. Another real great benefit is that if you get it adjusted just right, let's say something does go wrong and you have your hot end come down and hit the your glass or whatever, if you have this set right, it'll actually just allow it to slide up. Another thing too is it makes it super easy for setting. You know, I just can go ahead and zero out my machine, bring the Z all the way down, loosen up this set screw, put a 10 thousandths feeler gauge on it, drop it down, and tighten it up, and it's pretty much zeroed to my glass. This little, if you're wondering what this little tiny hole is right here, on originally my design had a piece of 1/16 inch music wire that basically would come out of there and it would spiral on up to the top end of the machine. It was a little heavier than it needed to be, so I changed it out, and now I just use I think it's about 30 thousandths, and it's adequate. It holds it really nice, holds the form, but that's what that little tiny hole is. This first hole was a fail. I'm not sure why, but the drill bit was pretty small, and I think it got hardened the aluminum, and I couldn't get it to go any further, so I stepped it over. Anyway, this collar is just JB welded to this aluminum plate, and I did put a couple of fasteners, 3 fasteners in it. They're little tiny 632 stainless steel screws, and and it worked really good. Centered it up. These are oversized. The holes that go through here, through this plate, are oversized. They're 1/4 inch instead of about 0.1, 0.17 or so, which is what you might want to use for 632. And the reason I did that is just so I had a little bit of play, I could really get it dialed in and centered up. This one, I put the information for the hot end, and I actually bought the entire kit. It's from that QU, those guys that make the whole extruder assembly. Now, as you can see, I didn't use the whole thing, but I did use the aluminum block. This little aluminum block that's in my feeder is from that kit, and it didn't have the right threads. Of course, it's a metric. I think it's a 6mm or something of that sort. So I went ahead and changed it. I just JB welded my own little tube connector here, and then I did machine out this bolt. This is a metric bolt that I machined out, and it's kind of, I used a starting drill in my lathe to go ahead and machine that out so it's funnel shaped on the inside of there. That way the filament just feeds right through all by itself. This is my work right here. Originally I had, I'll go grab it. Originally I had bought a pair of these. It was from, I think it was buildlog.net. That guy's got a pretty nice website, makes all kinds of stuff. Anyways, I bought one of these from him, and I actually had it in my extruder, and it worked great. But I needed something to print, to test out on. I found this on Thingiverse, so I thought, you know what, I'm going to try to do that. And so my first one turned out actually pretty good. This is my second one, which was much better. But man, it's really fun to be able to make parts you actually use in your machines. I think that's so cool. This is the stainless steel collar that comes from MakerBot, I think it is, and it's been working really well. I've had absolutely no problem feeding, and it even has to have enough force to pull my fiber in from the reel that I have sitting horizontally. By the way, that reel, somebody was asking, the reel is sitting on a machined piece of Delrin. It might be Teflon, but I think it was UHMW or something of that sort. Anyways, it's extremely low friction, so the spool turns really easily, so there's very little effort that the feeder needs to use up to pull it in. But you know what? This came from China. I think actually, if you find the right link for this little gear motor, it was only like $42 or $43, something like that. Unbelievable! I pulled it all apart to look at it, and it's actually really well made. For the money, you just can't beat it. And that actually comes with the stepper motor too. So I'll see if I can dig out the link. I bought quite a few of them when I found it. I'll see if I can find the link and give it to you guys. Anyways, yeah, this works really well. This was machined on my CNC, and it's got so few parts to it, really. Here's a close-up of the little magnets that I use that just snaps on. You can literally remove this part in just a matter of seconds. But let's see, what else can I show you? I think I'll take the camera and show you some other stuff. Okay guys, I'm going to hold this and see how well this works. Anyways, I just wanted to show you, this is something I designed that I think works really cool. A lot of guys you see using some kind of a bolt that they use for adjustments on their switch. I wanted to do it a little differently, and what I did is this is actually more or less spring-loaded. And what I do is I adjust the height of the switch as the carriage comes up. So you can see, I'm bringing the carriage up, and you can see it activate the switch right there. So I did that for a couple reasons. I just wanted it a little cleaner on the bottom side, and also to have real fine adjustability. This little screw down here, it's got a piece, it's a countersunk screw that actually has a little countersunk washer, nylon washer, so it turns really easy. And it's got a little bit of very little clearance with this nylon lock up here. So I can put a little, it's got some drag to it, and it keeps, makes it so that there's no lash in it. These little guys, they're used in aircraft, building aircraft, and I just had a bunch of them, so I used that. I'm sure you could devise something else, or just put a piece of heavier aluminum and tap it. But about a quarter turn on this is roughly around 4 or 5 thousandths, I think, that it moves. So it gives you really fine adjustability, you know, for each end, and works pretty well. You can see this is how I adjust the tension on my belt with this guy. And the reason I put these here, really, this was an afterthought. Although it's going to work nice, I want to build a little fascia that goes around here, you know, to just hide a little bit of this stuff up here. But it'll just wrap around, be triangular shaped. And but these little things I put here because it's very easy for me to pull off my my filament, and then what I can do is flip the whole machine over. I can flip the whole thing over on the ground, and it actually sits on this. If you look, these clear. It clears everything on these little feet. And so what I can do is just throw it on the ground, and that gets me to the underside where the electronics are if I ever need to get down there to work on anything. Here's that little Delrin piece here. You know, it's super slippery, and the spool just turns on there with almost no effort. So it worked cool. One other little thing that's kind of neat, I love magnets. And this little guy, you know, you can move this around and then just snap it in place. You can't see the magnets. The magnets are actually buried on the back side of this and on the back side of this plate. So it's just kind of neat. It holds it there plenty good enough so that you can work the controls. And anyways, yeah, that's it. I'll do another video. I'll pull this apart and show you my my heated Platen, and do that on another video. You can see my little music wire. This is way overkill because I did have a big heavy 16th inch, and I realized, hey, that's not necessary, so I changed it out, and now I just have this little 30 thousandths music wire. But it does a good job of keeping the you know, keeping it nice and coiled, keeping the shape on it. This is just this thin stuff somebody was asking. This is just thin thread that I just laced down to tie those two together. Originally I had this bout-in cable inside the this expanded sleeve, but it was too much of a pain, so I just went ahead and laced it with some thread. It works good. There's the end of that little stainless steel wire where it goes into the top of my hot end. So here's a close-up of the carriage, so you can see that. Now the carriage is connected to the belt, and I'm going to try to get this shot here for you. See that nut right in there? That's connected to the belt, and so it's really quite easy to do a belt change. You just loosen that up. I machined those out and engraved the grooves in there, which might be more difficult for somebody that doesn't have a CNC, but I'm sure you could devise something that basically gets the same thing done. So so you can see it. The belt's down in there. Sorry for the camera shake. Anyways, hey, if you guys haven't tried these out, man, Inventables has these linear rails with these little V-groove Delrin. This is a nice piece of work. They're beautifully machined. You can get it dialed in to where there's I had them set up so that you'd let go of it and it would just ride down at a nice slow pace all by itself. You wouldn't have to touch it. That's how well they, how nicely machined that part is. These are the little eccentric nuts right here, so you can adjust the preload on it, and that's something I really like. You know, you can spend a lot of money on linear rails, you know, that do the same thing, but this provided structure. It was aluminum versus the steel, and you can adjust the preload on it, which is just fantastic. And I don't know, it just really works nice. Anyways, good luck, guys. Happy building. Hey, one last thing I wanted to mention. was the balls. The magnetic balls are fantastic, but you still get, if you got any metal shavings around, man, they'll find their way to these balls. The easiest way to clean them up is to just take some duct tape and just wrap the duct tape on them and then peel the duct tape off. It'll take every little shaving off. And then that's one thing I definitely do before I put them, snap them back, is make sure they're ultra clean. You know, once they're cleaned up, that should last forever. You can see I got quite a bit of time already on this on these pads, and they look like when I put them on, so they're going to last a long time.